8. Today we're going to be talking about scale drawings. So what is a scale drawing or a scale model? So basically it is, they're used to represent objects that are too big or too small to draw or build at actual size. So if I was going to draw a picture of a building, I would need to be able to scale it down so I could fit it on my paper. But if you were trying to draw like a cell or a really small bug, you might have to blow it up or make it bigger. So whether you're making it bigger or smaller, as long as you're changing the size, that's talking about a scale. We're making it a different size. So basically this is very useful if you're trying to read a map, or if you're an architect and you're trying to draw a sketch out of where you want everything to be in the building and how far apart you want them to be. This would be a skill that they use in daily life. So basically a scale. So we have a scale drawing, but how much do we scale it down or scale it up? That is talking about a scale. So a scale is a ratio. Yes, we're going to be talking about ratios again. So a ratio that compares two things. It compares the drawing or the model that you're making to the actual size. So you're saying like 1 centimeter on my drawing is representing 4 feet in real life. Or you can write it as a fraction form, so 1 centimeter to 4 feet. Either way you write it, it's okay. Alright, now, something that's a little bit different than a scale, but similar to a scale, is a scale factor. So what makes a scale factor different from a scale? So basically a scale factor is a scale, but it has the same units and it's simplified. So instead of saying 2 inches equals 3 feet, we're going to say how many inches per inch. So basically, 2 inches are representing how many inches down here. So first thing, you're going to have to draw on a lesson we used in the past chapter. You're going to have to be able to say, how many inches are in 1 foot? So that'd be one question you want to ask yourself if you're changing this scale to a scale factor. So I know that there are 12 inches in 1 foot. So I'm going to have 2 inches, and I'm going to keep the inches the same because we're going to keep the inches in the top because we want the inches in the bottom as well. So we're going to say, okay, 3 feet. We're going to multiply that by 12 since there are 12 inches in 1 foot. And then we're going to get 36 inches. So basically now we have 2 inches to 36 inches. So now we're going to go ahead and cross off the inches. We don't need that anymore because we're comparing the same unit. And then we're going to simplify it down. So divide by 2, and we're saying 1 to 18. So this would be a scale factor, and this is a scale. So that's the difference between the two. Alright, let's go ahead and do some examples. Let's look at example number 1. So an example of something that you're going to have to do is say, okay, well here's my drawing, and I gave you the scale, and we're going to go ahead and you're going to tell me how wide would this be in real life. So if 1/2 of an inch is representing 4 feet. Now in this case I blew this up a little bit, so this is going to take, that's representing 1/2 an inch, this whole box. So basically we have 1/2 an inch is equal to 4 feet. Now the reason why what we're doing here is setting up a proportion. So we have two ratios. We have 1/2 an inch is equal to 4 feet. Now we want to figure out how many feet is this in real life. So we have x feet down in the denominator. Now I want to keep both of my feet in the denominator because that's the actual size. So we're doing the drawing to actual. So we want to keep it nice and proportional so that we can solve for the right thing. So we have our x feet down at the bottom, and we're going to go ahead and figure out how many inches is this wide in my drawing. So in this case, this is representing 1/2 an inch, so 1/2 an inch, 1 whole inch, 1 1/2, 2 inches. So we have 2 inches here. So now we're going to go ahead and do our cross multiplication to solve for our missing variable, which is x. So I'm going to go ahead and do x times 1/2, which is going to be 1/2 x is equal to 4 times 2. So 2 times 4 gives you 8. So now we're going to go ahead and solve for x. We have a variable multiplied by a fraction. So in order to get rid of this fraction, we need to multiply by the reciprocal. So remember, several lessons back, we multiplied by the reciprocal to cancel it out. So I'm going to multiply by 2 over 1. So I took the 1/2 and I flipped it and multiplied by 2 over 1. So that's going to cancel that out. So now I'm going to multiply this by 2 as well. So 8 times 2 gives me 16. So that means what? 16 what? 16 puppies, 16 what? So we were solving for feet. So this is going to represent 16 feet in real life. So basically my drawing is 2 inches wide, supposedly 2 inches wide, and that is representing 16 real feet. Alright, let's go ahead and look at example number 2. It says a scooter is 3.5 feet long. Find the length of a scale model of the scooter if the scale is 1 inch is equal to 3/4 feet. So I'm going to go ahead and write my ratio first. I'm going to take my scale and put it over here so I can start setting up my ratio. So 1 inch is equal to 3/4 of a foot. And I'm going to set up my ratio by keeping inches in the numerator and feet in the denominator. So I have my model, my actual size. My model, my actual size. Okay, so I'm going to go ahead and plug in the part I do know, which is 3.5 feet. So I'm going to plug this in the denominator because it's going along paired up with the feet over here. So 3.5. So that means we're solving for inches. So whatever my number ends up being is going to be inches. So I'm going to go ahead and do 3.5 times 1, which is going to give me 3.5 equals 3/4 times x. So 3/4 x. So now we need to do the same thing we did up here. How we multiply by the reciprocal, we're going to do the same here. So I'm going to be multiplying by 4/3, and that's going to cancel that out. And I'm going to multiply by 4/3 over here. So now we have 4/3 times 3.5. So I'm going to go ahead and change this 3.5 to an improper fraction so we can multiply across and simplify. So 2 times 3 gives you 6 plus 1 gives you 7. So we're going to multiply by 7 halves. So I'm going to cross cancel. So I'm going to have 2 over here and a 1 right here. So 2 times 7 gives me 14. And then 3 times 1 gives me 3. So we're going to go ahead and see how many times 3 goes into 14 just to make it a mixed number. So we have 14 divided by 3. So 3 goes into 14 how many times? It goes in about 4 times. That's going to give you 12. And you're subtracting, you're going to get 2. So 4 2/3. So 4 2/3 what? 4 2/3 puppies. What are we talking about? So we have x is equal to 4 2/3 inch. Because we were solving for inches, not feet. Alright, so that would be the size of the model. Let's go ahead and look at another example. It says, what is the scale factor of a model car if the scale is 1 inch is equal to 2 feet? So this time we're doing something a little bit different. We're not really setting up proportions as much as we're changing our scale to a scale factor. So we have 1 inch over 2 feet. Now the reason why this is not a scale factor yet is because we have different units. So what I want to do is say, okay, I'm going to take my bigger unit, which is feet, and I'm going to change it to inches. So how many inches are in a foot? I'm going to think that in my head, and I'm going to think that, okay, well there's 12 inches in 1 foot. So I'm going to multiply by 12. So that means I'm going to keep my inches here, so 1 inch is equal to 24 inches. So I'm going to cancel out my inches because we no longer need them. We're talking about the same unit. So we're just talking about 1 to 24. It's already in simplest form, so we don't have to do anything else. Alright, let's look at the last example. Now this one is going to be a little bit different. It says the scale factor is 1/12. So the size of the chalkboard. So what we're going to be doing is drawing a picture of a proportional picture to this chalk. Let's go ahead and measure our board real quick. So we need to know how many inches wide, how many inches tall. So I'm going to go ahead and measure the height. So if I measure it up, I'm going to see that it is 48 inches tall. So I'm going to go ahead and mark that down. So we have 48 inches tall. Now let's figure out how many inches wide it is. Alright, when we measure across, we'll see that it is 72 inches wide. So we have 48 inches tall and 72 inches wide. Alright, so we're going to draw a proportional model, or a sketch, down here. So what I'm going to do, our scale is 1/12. So we're going to go ahead and make this 1/12 of this size. So that means that if it's 48 inches tall in real life, we're going to go ahead and divide by 12 because 1 inch is representing 12 inches in real life. So we're going to go ahead and shrink it down. So if I did 48 divided by 12, we are going to be left with 4. So that means it's going to be 4 inches tall in our drawing. And then if I did 72 divided by 12, I'm going to go ahead and get 6 inches wide. Alright, so now let's go ahead and make our sketch. I'm going to get my ruler, and I'm going to go ahead and measure 4 inches tall. So it's going to be about here. And then we have 6 inches wide. So this little sketch, this little rectangle is 1/12 of the size of this board. So we shrunk it down, we made a scale, and we were able to draw it smaller. So basically, if you have any questions on this lesson, go ahead and rewind it one more time. You can watch just certain parts or the whole thing if you need to. You can also look in your textbook, and there's some examples that have already been done for you. And as always, bring questions to me in class. I'll be happy to answer them. Let's go ahead and do some on your own questions.
All right, you have 2 problems to do for me. Go ahead and read those and try to solve them. We'll see what you get tomorrow.